Hello friends, I welcome you to my YouTube channel MakePM. So in today's video we will solve a numerical problem based on stresses and strains. So let's read out the problem. The following observations were made during a tensile test on a mild steel specimen 40 mm in diameter and 200 mm long. So this is a specimen. Its diameter is 40 mm and length is 200 mm. Okay, and elongation with 40 kilonewton. So load is given as 40 kilonewton. Elongation is load is applied here, so it will elongate within limit of proportionality, because up to only certain limit it will follow the Hooke's law. After it will cross the yield strength, it will start plastic deformation and it will not follow the Hooke's law. That's why it should be within limit of proportionality, because if you draw a stress strain diagram, then up to certain limit Hooke's law will be followed, then it will become this like this, and it will be fracturing here, and this will be ultimate strength and this will be yield strength. So we can apply Hooke's law, which is equal to A is equal to stress upon strain. It will be only up to limit of proportionality. Okay, so that's why it is given. Now delta L, which is change in length or elongation, is given at this load. Delta L is 0.340 0.0304 mm. Okay, yield load is equal to 151 kilonewton, and maximum load Vmax is equal to 242 kilonewton, and final length, when it is elongated already, then final length is 249 mm. So Young's modulus of elasticity. What will be stress? Stress is sigma, which is equal to load upon area, which is equal to 40 kilonewton. 40 divided by pi by 4, area is pi by 4 d square. So d is 40 mm, which is equal to 0.04 meter. So if you will calculate this, you will get 3.18 into 10 to the power 4 kilonewton per meter square. Okay, now if you will calculate strain, then strain, sigma strain is E, which is equal to delta L by L, which is equal to, what is delta L? 0.0304 mm divided by initial length is 200 mm. So mm will be cancelled, it will be 0.000152. This is strain. Okay, so value of E is equal to sigma upon E, or equal to stress upon strain. This is equal to 3.18 into 10 to the power 4 divided by 0.000152, which will be equal to 2.09 into 10 to the power 8 kilonewton per meter square. So this is value of E, which is Young's modulus of elasticity. Now we have to calculate yield point stress. So what is yield point stress? Is equal to yield load, P yield load divided by area. So what is yield load? 161 kilonewton. So we will put the values of yield load. We will get 161 kilonewton divided by pi by 4 d square area. It is 0.04 square. So if you will calculate this, you will get 12.8 into 10 to the power 4 kilonewton per meter square. This is yield point stress. Now we have to find ultimate stress. So ultimate stress, maximum load. See here ultimate stress. It is ultimate stress. Maximum load is here. So maximum load is 161 kilonewton. So ultimate stress is equal to maximum load divided by area. This is maximum load is 161 kilonewton divided by pi by 4 into d is 0.04 meter. So this will be equal to, sorry, this was not 161. This is actually, you can see here, it is 242 kilonewton. So here it will be 242 kilonewton. So if you will calculate it, then you will get 19.2 into 10 to the power 4 kilonewton per meter square. So this is ultimate stress. Now we have to find percentage elongation. See, what was initial length? Initial length was 200 mm and final length is 249. So percentage elongation is equal to final length L final minus L initial upon initial length L initial into 100. So it is 249 minus 200 divided by 200 into 100, which will be equal to 49 divided by 2. It will be equal to 24.5%. So we have calculated all the values which were asked in the question. I hope you understood how to calculate this. If you have any doubt, then please ask in the comment section. And if you liked our video, then please subscribe and share our channel. Thanks for watching.